So here's what I hope will be a helpful cheat sheet for you guys to compare the different types of alcohols you could start with and the stereochemistry that you'll get at the end. All of these reactions, remember, are going to convert alcohols to good leaving groups, but they are going to proceed with different stereochemistry. So because this section has so much to do with stereochemistry, that's why I made this entire axis all about just stereochem. All right, so let's go ahead and start off with, what if we want a good leaving group, we want to convert alcohol to a good leaving group, and we want the end product to be racemic, okay? Well, if that's the case, then we could start with a secondary or a tertiary alcohol, and we could use HX in an SN1 reaction, okay? HX is the only reaction in an SN1 that gives us two enantiomers, that gives us a combination of products, okay? Now you might be wondering, well, Johnny, why is it grayed out here? Why can't I also use that on a primary alcohol? Okay? Well, remember, because primary alcohols don't form good carbocations. And in order to make a racemic mixture, you need the carbocation. So I'm just going to write here, can't make carbocation. And if you can't make the carbocation, that means you're going to do an SN2 mechanism, not an SN1. So that's why it's grayed out. Okay? Now, one more thing I just want to add. Remember that what happens in the case of HCl? Can I also just use HCl by itself? No, remember, we use or the Lucas reagent, HCl over zinc and 2 chlorines, the Lewis acid catalyst. Okay? Cool. So let's keep going. What if I'm starting with alcohol and I want to get inversion of configuration at the end? I don't really care what the leaving group is as long as it's inverted, okay? Well, if it's primary alcohol, then I can use HX or SOCO2 and PBr3. So just so you know, SOCO2 and PBr3 are always good options for inversion, okay? Because of the fact that you get a backside attack every time. Why did I only put the HXSN2 here? Why did I not put it in the secondary position? Because if you guys remember, HX will actually, if you do it with a secondary, it's actually going to wind up giving you an SN1 reaction. So that's why we can't use it in the secondary position. We can only use it in the primary position. If you have a primary alkyl halide, you will get an SN2, you will get inversion. But if it's secondary, remember, you make your carbocation again, and you would form a racemic mixture. Okay? You might be wondering, well, Johnny, why is this grayed out? Why can't I just do an inversion of configuration on a tertiary as well? Why can't I use SOCl2? Because remember, you can't do a backside attack on a tertiary. It's too crowded, okay? So I'm just going to put here bad backside. Since it's a bad backside, I can never do an inversion of configuration on a tertiary. Cool? All right, so lastly, what if I want retention of configuration? I don't really care what the leaving group is as long as it's good, and I don't want it to be alcohol, obviously. Well, anytime you want retention of configuration, you're going to use your sulfonyl chlorides to turn your alcohol into a sulfonate ester. Okay? This one's really easy because it doesn't matter what degree your alcohol is, it always works. Primary, secondary, tertiary, it's always the same thing. You're going to wind up getting a sulfonate ester. And it's that easy. And then later on you can react it. Okay? So hopefully that helps you guys to kind of organize the different ways that we can convert alcohol to good leaving groups. Professors love to test on stereochemistry here, and that's why I would really emphasize knowing the differences in stereochemistry between these options. All right? So I hope that made sense to you guys. Let's go ahead and move on.